So children, as we discussed in our introductory video, we can start with a new concept of this chapter, that is force acting on a current carrying conductor when it is placed in a magnetic field. First, let's focus on the concept, that is, why does this conductor experience a force when it is placed in a magnetic field? What could be the reason for the force experienced by this conductor? So let's try to explain this concept through an experiment. So just have a look at the experimental setup of this experiment, and let's have a close look. See, this is the experimental setup to explain the force acting on a current carrying conductor. Here you can see a magnet. And what type of magnet is this? Yes, you are right. It's a horseshoe magnet. And it's the north pole. It is the south pole of the magnet. Now, what is this? Can you see this rod? This is an aluminium rod. And you know, aluminium is a conductor. So, this is our conductor. One end of the conductor is marked as A, other end is marked as B. Now, A and B, ends A and B are connected to the battery. So, this is our battery. So, end A is connected to the battery, to one side of the battery, and from other side of the battery connection goes to switch. Now, from the switch again connection goes to end B. That means end B is connected to the battery through a switch. And our conductor is suspended from a rigid support or a stand like this. Hope the experimental setup is clear to you. Our conductor is placed in the magnetic field of horseshoe magnet. Why? Our conductor is now placed inside the magnet. And inside the magnet there will be the magnetic field produced by this horseshoe magnet. And what is the direction of that magnetic field? Yes, it will be pointing from north to south. So upward. The direction of magnetic field will be upwards. Now switch on the circuit. When the circuit is switched on, it was observed this rod is displaced towards the right direction, towards this side, right side. So if there is a displacement, there must be a force. Only a force can cause an object to displace. You had studied this fact in your class 9 physics, right? So what is this force, or which force is responsible for this displacement of the rod? Yes, it is the force produced by this magnet. Again, if this magnet is to exert some force on this conductor must possess some magnetic properties. Otherwise, horseshoe magnet cannot exert any force on this conductor. So, since horseshoe magnet is able to exert its force on this conductor, we can conclude that this conductor is also a magnet. Again, we had studied in the first session that whenever current flows through a conductor, it behaves like a magnet. Do you remember our famous experiment by Hans Christian Ørsted? He is the brilliant scientist who discovered the fact that a conductor can act as a magnet when it carries a current. So when the circuit is switched on, current flows through this conductor, and this conductor is a magnet now. Okay, so we have two magnets here. One, this horseshoe magnet, and another one is this conductor. So this horseshoe magnet creates a magnetic field, our conductor also creates a magnetic field because both are magnets and their magnetic fields interact and causes a force. So you may think, why does this conductor alone moves? Horseshoe magnet is also a magnet. So this conductor can also exert a force on our horseshoe magnet, but it's not moving. It cannot move, my dear children. Why? Because it is kept fixed here. Can you see this stand? Yes. So our horseshoe magnet is kept stationary by some arrangements here. Only this conductor is able to move. It is movable. Okay. So due to the force exerted by this magnet or due to the interaction between the magnetic fields created by both the magnets, our conductor experiences a force. It can be an attractive force or it can be a repulsive force. Okay, that depends upon the direction of current flow and also the polarity of the magnets. So many factors are there which controls this fact. Okay, anyway, it experiences a force. It can be either an attractive force or a repulsive force. Okay, so if it is a repulsive force, it is displaced towards towards the right direction, and if it is an attractive force, magnet attracts the rod towards it, so as a result the rod is displaced towards left. Okay, and it was also observed the force experienced by this conductor is maximum when this conductor or when the direction of current flowing through this conductor is perpendicular to the magnetic field. And we can come back to this fact later. Hope you might have understood why does this current carrying conductor experience a force when it is placed in a magnetic field. Why? Because of the interaction of the magnetic field produced by both the magnets. Next, let's discuss about the factors affecting this force acting on the conductor. So here, see, what is the direction of the magnetic field of this horseshoe magnet? It is from north to south. So this will be the direction of the magnetic field, upwards. Now suppose A is connected to the positive of the battery and B is connected to the negative of the battery. Right? So what will be the direction of current flow through the conductor? Yes, what is the direction of conventional current? It flows from positive to negative. So this is the direction of the current flow. Right? Next, it was observed when the circuit is switched on, it was observed that the rod is displaced to right. That means it is repelled. A rod is repelled by that horseshoe magnet. Now, just reverse the direction of current flow. Initially, the current was flowing from A to B. Now, just change the polarity of the battery. Now, connect end A to the negative of the battery and end B to the positive of the battery. So, what is the direction of current flow? Current flows from B to A, from positive to negative. So, just opposite to the initial direction. This time, the rod was observed to be deflected towards left. That means towards the magnet. So, the magnet is attracting that rod now. So, what can you infer from this? Yes, the direction of force is also reversed when the direction of current is reversed. Which is the first factor which influences the current flow through the rod? Yes. Increase the potential of the battery. Suppose the potential of the battery was 2 volt. Now it has been increased to 6 volt. So what will be the result? Yes, more current starts to flow through the circuit, right? So it was displayed and it was observed that the effect of that force, that means the displacement of the rod, was greater than the previous case. That means when the potential was 2 volt, the displacement of the road was less. But when the potential is increased to 6 volt, the displacement of the road increases. Okay. Displacement increases means the force experienced by the road increases. So when the potential of the battery is increased, the current flowing through the road is also increased. So obviously the force experienced by the road depends upon the current, magnitude of the current flowing through the conductor. So which is the second factor, my dear children? Magnitude of the current flowing through the road.